That's right.
Hello folks, in this tutorial we will learn about list data type, starting from some basic concepts to using built-in functions available in Python. As you can see, Python has many different data types and list is just one of them. If you want to learn about all these different data types in Python, I have another tutorial video just for that. You can get the link to that video in the description down below, but in this tutorial we will strictly work with list data type. In a nutshell, list is one of the most used data type in Python and is very flexible. List is an ordered, mutable sequence of items and is used to store multiple items in a single variable. Before we begin, don't forget to hit the like and the subscribe button to get more contents like this. So let's get into it and get some real valuable skill in working with list data type. So we're going to start with a basic example. How we create list in Python is we use square brackets and items in the list are separated by commas. So an example like this, when we run this, it would just print out from the first element to the last element. A list doesn't always necessarily need to have multiple elements. We can only have a single element and it still be a valid list. So for example, we can just say 0, and when we run that, it would still be valid. It doesn't always have to be numerical value or a single data type within the list. It can have alphanumerical value. Let's say an example like this, and separated by comma for a single element list, and that would still be a valid input. We can do print type of this numbers, and when we run this, it would show us of list data type. We can also create a list using list constructor from other data types. So let's say an example, we have a tuple with elements 1, 2, and 3, and what we can do is create a new list out of this tuple. And how we can do that is by something similar to this. So we have a tuple here, and with this list constructor, we will get a new list called myList. And we can see that when we do print myTuple and the type of myTuple versus print myList and the type of myList, when we see the output here, we can see the first one is a tuple and the second element list. As mentioned earlier, the list does not need to have elements of same data type. So when we say something like mixed list, now it has integer value, floating point number, string, another string here, a boolean value, a non-data type, and a list within this list. And this is called a nested list. So like in the previous example, when we do print mixed list and print length of mixed list, it would give us the whole list and then print that it has 7 items. Now when you count this, 1, 2, 3, 4, 5, 6, and this list itself is one item within this list. So it won't be counted as 2 different items, but one single item, and then the total item is 7. Now let's talk about indexing in list and accessing list items. So let's say we want to see what is this item, or read the value of this item that is inside this nested list. For that, we need to understand how indexing work. When we have a list like this, the index value of the first item will always be 0 and increment by 1 each. So this would be index 0, 0, index 1, index 2, index 3, 4, 5, and 6. It also has negative indexing, so the last item will always be indexed -1, and then the next one would be -2, -3, and so on. So it would be easier to just use the same example and have the printout of this index values. So here what we are doing is I'm using the same mixed list, and I'm printing the first item given by index value 0, and it would give me 100. The third item 0, 1, 2, 3. So this would be the printout. And now here is the -1, which is the last item. So last item itself is another list here. So it would give us 1 and 2, that nested list. Similarly, the third last item would be a boolean value of true. And then here we have provided 2 different index values here. The first index value will provide the index location of the element within the main list. So this -1 is saying we're looking at the last item in this list, which is a list of element 1 and 2. And then the second index number 1 is telling us to look at the second item within that nested list, which is item 2. So you would just print out 2 here. I hope this gives you, this provides you enough idea on how indexing works. This concept is very important, as it is also similar to indexing in other iteratables in Python, such as strings. It is also equally important because this technique, this information or knowledge will be used in slicing technique and a whole lot of other stuff beyond just basic knowledge in working with list. List is also mutable and allow duplicate items. And by that, what I mean is if we have this original list here of the mixed list, and if I want to change some item, then let's say I'm changing the second last item given by index value -2 and assigning stop string to that index value, which is the item none. I can also assign element from one index value to another index value. So in this case, my fifth item would be 5, and I'm assigning that to the first element, and I'm printing out at the end of that. So what's happening here, well, this is my assignment or declaration of mixed list. And here, the second last item, which is none, I'm reassigning that to a stop value. So that comes here. I haven't changed any other item so far, but now in this statement, I'm changing the first element to get the value from the fifth element. So index value 0 will get the value from index value 5, which is stop now, because we changed it earlier. So the first item would also be stop. And this is basically how we access or read and write element in list using index values. Sometimes when we work with index value in the list, we get an error message because the value we provide could be out of index, meaning that the length of the index is not as long as the value we assign here. So let's say mixed list 15. So we don't have an element 15 in this list, which is not that long. And when we try to run this, it would give us index error. So that's something that we need to keep in mind when using or working with index or index value for a list or any iterable data type for that matter. And that's exactly why it's easier sometimes to learn about the length of this iterable or sequence. And how we can do that is just use a length built-in function, and it would look something like this. In this case, we have a mixed list, and all we're trying to do is print the length of the mixed list, and that's given by this length function. And when we print this, it would give us length of 7. We can check if an item exists in a list, and how we can do that is using a membership operator in and providing a mixed list. So what we are doing here is we're checking if example exists in the mixed list, and if it does, we were printing it exists. Otherwise, we're printing it does not exist. And in this case, since example exists in our given list, it will print exist. Now, if we were to change the code here and say instead of examples, we are saying example, make it singular. Now it doesn't exist in this list, so it would have to print out does not exist. And that's how we check membership, whether some element is existing in a big list or not. Next, we're going to look at slicing operation. Slicing operation in list is very important technique. So let's say we have this mixed list, and I'm going to run this now and then later on explain what's happening step by step. So here we have this starting list, mixed list. And by this statement in line number 2, all we're doing is printing that list here. In the next line, we're printing item number index from 2 to 5, and 5 would not be included here. That's something that we have to keep in mind. It would start from index value 2, but stop before index value 5. So index value 2 would be examples 3, 4. So this is all that would be printed out, and you can see that in printout on the console. Now, instead of 2, if we were to say 0, that would start from the beginning and print everything from index value 0 up to that point, which is similar to saying not providing anything in the beginning of the slicing. So if we were to say blank semicolon 5, that is the same as the previous statement, and it would give out the same output again. Slicing also works with negative indexing. So if we were to replace the 5 with -1, which is the last item in this list, so it's gonna start from the beginning and stop at the last item, excluding the last item. So last item here is another nested list. And by this statement, it would exclude that last item and print everything else. And this is the output we see. Now, instead of in the beginning, if we leave the ending or trailing value blank, that would mean that we're starting from negative to index and going all the way to the end. So we would print these two items. And of course, if we don't assign anything in the beginning or the trailing numbers, that means we're printing everything in this list, and that would give us this last output on the console. With this slicing technique, we are now capable of learning further techniques to update a list. So far, we haven't updated anything in the list. We are just accessing the value, but we can easily do that. First, let's see how we can use slicing technique to replace values in a list. I'm just excluding the nested list at the end of this for this example. And here, what I'm doing is I'm looking at the first element, or the index value 1 to 2, excluding 2. So that would just mean this one item. And for that one item, I'm replacing that with another list which has two elements here, and I'm printing the new mix list after the update. Now what this is doing is it's taking one value from the original list and replacing that value with two new values. So this would essentially increase the length of this mix list by 1. When we run this, we are seeing, instead of 9.4 and on the index value 1, we are seeing list that we added in place of that. Basically, we replace 9.4 with this new list. Now in line number 4, we're using the slicing technique again. So we're starting from index 1 to 3 and not including 3, so 1 and 2. So our new mix list is this, so 1 and 2, and we're replacing that with list of single items. So 9.4 is the element there. And we're replacing this with our original 9.4. So we revert back to the original mix list that we started from. We can also use slicing technique to empty a list. And how we can do that is basically say from beginning to end, I'm going to replace with an empty list like this. And when I print mix list, I'll see the output here. Now, how can we insert item to an existing list? Let's say this is our existing list. We're going to use insert method to add a new item in the middle of this list. So here I'm printing the list and printing the length of the original list. In line number 5, I would use insert. It would take two parameters. The first identifies the index value where I want to insert, and the second value identifies what element I want to insert into that index value. After that update, I'll print the list and the length of the list. So let's run and see. So this is the original list with 6 items, and after the update, I added watermelon in index value 2, so 0, 1, and 2. So this was the index value 2, and at 2, I inserted watermelon, so everything shifted 1 to the right, and watermelon got inserted there, and therefore the new length after the update is 7. So instead of using insert, I could use the append method to append item to the end of the list. And that would look something similar. Here's the code. I have the same mix list that I start with, getting the printout and the length of this original mix list. And now I want to append watermelon not at a given index value, but with this append method, it would just add a new element into to the end of the list. And I want to run this. This is the original with 6 items. Now I have 7 items with this watermelon appended at the end. So that's what the append method does. This is one of the most important methods when we work with lists. There is remove method to delete items from a list by item value. Let's say we are working with our list there, and instead of append, we are showing remove, and I'm removing item 100. Not item or index number 100, but item 100. If that value exists in the list, then it would remove it. And then I'm going to print the updated list again. So I had 100 in the beginning, and with this remove, I'm removing that item from wherever it occurred and printing out the new list. Now let's see what happens when I have two occurrences of that same item. And in this case, it only removed from the first occurrence, but this one is kept there, and accordingly our list only decreased by length of 1. There's another method that is built into Python that is used to remove item, and that is pop. It is different from remove because it doesn't use value but index value instead of value. So if I want to remove a certain number, say 0, I'm using index value 0 and removing the first item. I could use this method to also remove the second item 100 here, which is index value 3. And this time I have this original the beginning 100, but then I remove the second 100 based on this pop 3. We can not assign an index value there, and what that does is remove the last item from this mixed list. So last item is none, and with that pop it removes the non item, and we can repeatedly do this pop method and reduce the size of the length by 1 each time. This is particularly useful when we work with, for example, drawing a card from the top of a shuffled deck. We can also update a list, or more specifically use delete keyword to remove item from a list provided by an index value. So for example, let's say I have a mixed list, again, something like this, and now I'm deleting mixed list index value 5. Yeah, it correctly removed value none or non-data type, which is the fifth element, and reduced the size of the list by 1. Delete keyword can also be used to remove a list completely. So instead of providing an index value here, if nothing is provided, you would just delete the mixed list, and when we print, it would probably give a name error because we have removed it. Mixed list is not defined, basically. If we don't want to delete the whole list or completely, but rather only want to clear the list, there's a clear method that we can use that would look something like this. So we have this same list, and we're going to use clear method over that mixed list to clear the elements. The list itself is still existing, it just doesn't have any element within it. How about working with different multiple lists? So let's say we have mixed list and then new iterable. It doesn't necessarily have to be another list. Here, this is a tuple, and I'm using the extend method to basically add these two iterables together. So I'm mixing mixed list with the elements that are in the new iterables, and when I print out, it would give us what is in the original list with the two items that I added from the tuple, and the total value would be 9 instead of 7, the length. There's another way to join, and that's probably the most easiest way to join two different lists. Instead of tuple, I would need my new iterables to be another list. So let's say this is my mixed list and new iterables. The extend would still work with two different lists like it would with list and tuple. But what I want to show is how we can just use a plus operator to concatenate two different lists. So mixed list will be added with new iterables. With this, the addition or concatenated list will be printed out. And like I said, this is probably the easiest way to join two different lists. There's a short method that short lists alphanumerically. So for that, let's run and see. This is our original list. The first shorted method will give this output, and the reverse, when we do reverse equals true, that means we want to sort in the descending order, not ascending order. So that would be our final output. If we want to mark this as false instead of true, that would be same as the same of a previous method. And when we run this, we get two outputs with the same result. There's also a reverse method that is used to reverse order of element. So something like this. We want to print the mixed list and also see length of the mixed list after the reverse. We had 3 elements in the beginning, and we reversed the order of the element and printed out the updated mixed list. Now there are other useful functions other than functions to update a given list, such as copy function. One important thing to note about a copy function is we cannot rely on this way or this method of assigning new variable name to make a copy of the existing list. Let me show you what I mean. There are 3 similar output here, and that's because we are making copy list or refer to mixed list basically. So this would be the length of copy list, this would be the length of mixed list. When we made change to mixed list, that change is also reflected in the copy list. But interestingly, both are of same addresses. So it's not basically not a copy of one list made into another list, but a new reference variable that is still referencing the same address location of the original list. So what I'm trying to say is this is not an elegant or a valid method of making a copy of a list. And for that reason, we have another method built into Python, and that is like this. So copy list would be mixedList.copy. And now when we do the address and the length and print out of these lists, we will see the difference. Now we have two identical lists of identical size, but then they have different address locations. And effectively what that means is one is a copy of another in a different memory location. There is another way to make a copy of a list, and that is with a list constructor that we looked at earlier. So instead of a copy built-in method, we want to use a constructor method for making a list, and our input variable or input argument for that method would be a mixed list. So copy list would just be a listed item of elements that is in the mixed list. Again, when we run this, we get two different addresses for the identical element and identical length of the list. The last two items I want to discuss in this tutorial is index and count method built into Python for working with lists. The index method basically returns the index of the first element with the specified value. So for example, if I'm assigning, if I'm trying to find the index of value 100, and if that occurs in the first element, then the index method would output index value of this, which happens to be 0 in this case. Similarly, the count method returns the number of elements within the specified value. So if I'm counting how many true Boolean value occurs, it would just count there's one true here and print out 1 as an output. So let's see an example. So this would be my list. I modified it a little bit. How I did is I have two different occurrences of element 100 and two different occurrences of non-data type. With this print statement, I'm first printing index value none, and that would effectively only print out the index value of the first occurrence of none and not any subsequent occurrences. And then I'm also printing out count of none. So we'll see, although there are two occurrences of none, the first element or first occurrence happened in index value 5, which is 0, 1, 2, 3, 4, and 5. So that is all for this video. I hope you learned something new. I will probably do one or two more videos related to lists, and one of those will be a multidimensional list or making an array and working with arrays. And the second would be list comprehension. So stay tuned for those. If you like the content of this video, please don't forget to like and subscribe again. Also hit that bell button so that you don't miss future videos like this. Until next time, thank you.